So, how do we handle the reactivity series? Actually, it's not too difficult if you know how the pattern goes, okay? We split it mainly into two different segments. The first one, we talk about the reactivity and the chemical reactions of the metals themselves. So we discuss very directly the element and how its reactivity affects the action of that particular element in a particular kind of chemical reaction. Then the second part of it, which is actually, frankly, the more difficult part, less direct, but that's the one that has all the essay questions, the 6 to 8 mark questions, all incorporated inside there. So that one will be slightly more complicated. The way that you think through it has to be different. Okay, so we'll discuss that in a while. So first, let's start with the metals. I'm sure you have watched my first video already, so you have already gotten, I'm assuming, that you have gotten the entire reactivity series in your brain, yeah? And you are actually quite familiar with it. So how do we discuss reactivity of metals? In terms of two different things, okay? When a metal takes part in a chemical reaction, how much starting energy does it need to kickstart that reaction? If you have a very reactive metal, it doesn't take too much, perhaps just adding the chemicals together and already it goes into an explosive kind of reaction. That is possible, okay? Now, if you are very unreactive, then maybe you need to actually heat the mixture up or heat that element and give it a good kickstart amount of energy so that it can start a chemical reaction, overcoming certain energy barriers at the start, right? Those will be for the less reactive metals or the very unreactive metals. Now, during the reaction, the second thing to look out for is how much energy is actually released during a chemical reaction with the metal. The more reactive the metal, the larger the amount of energy that's released, usually in the form of heat, light, sound. All right, heat being the first one, main one. All right, so this directly affects the temperature of the reaction mixture once the reaction actually gets started. Right, of course, then if there's a lot of energy given out or specific to certain metals like magnesium, which tends to like light a lot, then maybe a lot of bright light will be produced and stuff like that. So it all depends on the exact elements. That's why chemistry is fun, isn't it? All right, so the amount of energy that's released, okay, if you are a very unreactive metal, during the chemical reaction, you wouldn't release too much, all right? So then it will be a pretty mild thing. But of course, there's some compensation along the way. Now, lastly, of course, it is about the end product. How ready is it to stay as its end product? If a metal is very unreactive, and it does manage to get into the groove of that chemical reaction, it may actually produce so little heat and its end product could be so unstable that it may not actually have the ability to stay there. It might form, and before you know it, it has decomposed and gone back to itself. That is also possible. So you've got to watch out for that, especially towards the bottom end of the reactivity series when you're dealing with the most unreactive metals, aka silver, gold. Join my channel so that you can get updates for future video posts. Thank you.